All right, let's talk about homework 3 a bit. So, I don't need that. All right, so today I want to go through the handout code for homework 3 and kind of clean up any questions about homework 3 that are out there. I'm done with content for showing you exactly what I need to show you for homework 3, so homework 3 is completely in your hands right now. Next week, I'm going to do demos and tips and tricks for homework 3. And I decided to not do lecture questions next week. Not joking or anything. So next week, if I know there's the temptation to think that today, but next week there will be no lecture questions. So whatever decisions you want to make based on that information. And then the following week, we'll go back to lecture questions when I'm talking about the homework 4 material. So when I'm doing these examples in architecture next week, I'll do some WebSocket stuff. I might end up doing the Python stuff today, so I'll go more in depth next week, do some JavaScript examples. Then I might just do other examples, just kind of whatever the people who show up want to see. What? April 28th. Oh, yeah, I'm a time traveler there, apparently. That should say 8th, of course. Whoa. Does it always look weird like that with the... Is there a ripple in the screen? And I have one more week of review examples. So the examples that I want to do this week, I might just push to next week. And just whoever shows up, whatever they want to see, I might cater to. And then I'll have my default, what I'll go through if nobody has questions. But I might show like how to deploy apps. I always like showing how to get a domain name, deploying an app, and actually making it live out there on the internet. I might do that with WebRTC since you need encryption to be able to, either encryption or localhost to enable a WebRTC connection. I might show how to deploy a site. Oh, I took it down. How to deploy a site and then actually get 2 different devices connecting over WebRTC to see the actual power of what the technology can do. So I haven't started. I don't know. You still got 2 weeks. Honestly, not too much. You need to allocate time for homework 3, though. In my opinion, homework 3 is the hardest homework of the semester. So allocate time accordingly. However long homework 2 took you, this one's going to take you longer. There's no sugarcoating. There's no getting around that. It's just tricky to parse frames. Parsing frames is one of those things where conceptually it's not too difficult. I'm sure you can all follow the slides when I'm talking about the bits and all that stuff. Putting it to code and getting every single bit exactly right takes time. It just takes a lot of time, takes a lot of debugging cycles. I strongly recommend using the testing that we learned in 116 to do that. Write some unit tests. Anyway, Python has an assert method just built in. If you do assert, like you can basically build unit testing into your main method. Just write a main method and do assert. The problem is, which really pissed me off when I found this out, if I do projector mute, like you can't see what I'm doing, right? That's the whole point of that button, right? It still captures it for the video, though. So anybody watching the video still sees the whole thing. So I have to unplug it, wait for my laptop to register that a second monitor has been disconnected. I just don't feel like doing all that. It's not worth it just to show you, look, assert is a function in Python. But assert is a function in Python, so without even importing any testing libraries or frameworks, you can do some form of unit testing in Python. So I recommend doing that. Write a main method and do that. It's going to cut down your debug time significantly for this homework.
Jesse, does it require us to set up the connection first to get the frame?
Yes, kind of yes and kind of no. So what I did for testing is set up the connection, get a frame, print out the byte string of that frame, copy that into your unit test, and then you don't need a connection thereafter. So just do the connection one time to get a frame for your test case, or 2 frames. Once you get 1 frame working, get another frame that where the 7-bit payload length is going to be 126, and then a 3rd frame where it's 127, and make sure you're parsing all of those properly. right, so let's just go through this stuff. I want to do it in PyCharm. Yeah, it's going to take a while. Nicholas, there's no way you're still on objective 1. Are you, for real? You're. Oh. Yeah, you're ready to work on this one for 20. I don't know. I kind of go back and forth on the difficulty of the assignments. What I really need to do is just audit like all the other courses and see what my relative difficulty is. Pretty on par. Okay, so I can kick it up a bit. I mean, it won't be this semester anyway. You can say, yeah, double the difficulty. Because when I look back at the assignments, like, you're not really doing that much. Like homework 2, you were parsing the multi-part form requests. Like, I'm sure other courses are making you do a lot more than that. It's just a little bit of string parsing. But you have to do it in the world of bytes. But in Python, it's the same. The bag is so loud, just so you know. So it's something I've been thinking. But when I look at homework 3, like I see that as being where the difficulty probably should be for homework like this, for a 300 level class, for being 1/4 of the semester. I think homeworks 1 and 2, 1 I increased a lot this semester, but I still think it's a little easy. Homework 2, I think it's too easy every time I look at it, but I know how much trouble it causes. I know how frustrating it is to go through. So I don't know what to do there. Either increase the difficulty and just do what every other course does, increase the difficulty and just throw a big curve at you and say, whatever, if you don't do it, fine. Seems like a lot of, way too many courses do that. Where I don't have a curve, I say 70 or fail. So I can't make the assignments too difficult unless I budge on there. So anyway, I'm just kind of thinking out loud. Let's go through this stuff. Yeah, even I fell for that one. I'm like, oh, the TAs got released grades last night? Awesome. Apparently not. All right, so here, the front end, not a whole lot going on the front end. For the code that I give you, it's just pasted into the document. There's a chat form. This time the form only calls a method. So we're not actually, I shouldn't even say form. So we're not actually using HTML forms. Now that we know what Ajax is, I'm going to leverage that on the front end. On the back end, handling an Ajax call is about the same as handling a form submission. The big advantage, though, is that we don't have to parse multi-part form requests. So anybody who didn't get that on homework 2, you don't have to do that moving forward. I don't like cascading failure. Some of it has to exist in this class. Like if you still don't know how to parse an HTTP request, like that's going to cascade through the whole class. Hopefully everybody can parse an HTTP request by now, though. But if you couldn't parse multi-part forms, which is a bit more involved, I don't want you to automatically not be able to do homework 3 either. So we are using Ajax. Now we know what that is. The advantage is when we call send message, we get to send a JSON string. Oh, we're using WebSockets anyway. What am I talking about? Even if we weren't using WebSockets, though, we could send an Ajax request with JSON data instead of using multi-part forms. The disadvantage of that is you can't quite send a file. You can. Is that true? I guess I can guess myself. I think if you send a file, you have to use multi-part. Does anybody know if that's true? Why don't I know that off the top of my head? I've never sent a file without a multi-part form request, because that's just the way you do it. If it's possible to do it another way, I don't know. I'd have to think about that. I want to say no, actually. But anyway, we're going to call a method. So I don't actually have a form. There's no form element here. I'm just going to have my text box with a label still. Always put your labels for things like screen readers. And so you can click on chat. If you click on the text chat, it will highlight that input. So even somebody not using a screen reader, it's still helpful for the rest of us to be able to just have a little bit of user experience in there. Especially, I know I've said this before, but especially for radio buttons, when you have those little circle buttons, and don't make your users click exactly on that circle. Let them click the entire text associated with that radio button. It's just helpful. So always put your labels with the for matching the ID of the element. And then a button that's going to call send message, which is going to grab this text and then ship it over the WebSocket. I'll go through all the HTML since there's not much, and then we'll talk about the send message method later. And then an empty div with an ID of chat. That's where all the chat messages are going to go. So we're not rendering HTML in this objective either. The rendering is going to happen on the front end. So we're inverting the rendering as well. And this is common out there in practice. Template engines so the two choices are template engines on the server side, like we did for homework 2, or rendering templates client side, like we're going to do for homework 3. Those are the two choices. I think it's pretty standard to have that happen on the client side these days, especially when we have so many client side libraries out there that people like to use. Like those are going to render the data from your server, and then your server is basically going to be almost just an API. So like the API we built in homework 1, the client's going to say, give me all the images, give me all the chat messages or whatever. Your server's just going to send a big old JSON string with all the data, and then the front end's going to interpret that and turn it into HTML. That's, I believe, more standard. I don't think very many servers are using HTML templates these days, at least in part because they're expensive. It takes a lot of server processing power. You can get your client to do that, that's one reason. The other reason it's slow. Doing it this way, your page can load faster, and then the data populates, which you see all the time on the internet. You click something, the page pops up like right away, very fast. That load time is very important for usability. It's a very short amount of time we're willing to wait for a page to load before we just go to the second search result in Google. We're going to give up real quick. So that time to load is very important, and then the data actually starts populating through Ajax calls, and then is rendered into HTML on the front end. Very standard, very common these days. And then we have two buttons, start video and connect WebRTC. I also have two video elements here. Playing videos in the browser is actually super easy. You just put this video tag, and then this acts the same way as a source, as an image tag for images. We could put a source here. If I add an MP3 hosted, maybe I should do that, obviously not today. But if you do an SRC and then put an MP4 file, any video file, it'll just play the video just like putting an image on your page. It's as easy as adding an image to your page if you want to add a video. Super simple. But we're not going to put any video data in these because we want them to be used for our WebRTC connection. So I'm just going to leave them empty, but I'm going to give them IDs. I'm going to autoplay them both, so when the stream starts, you don't have to hit play. And I'm going to mute the one that's going to be showing your video, so you don't have your audio being captured by your own mic being rendered through your speakers and getting a lot of feedback and stuff. Which you will anyway, because we're going to test on localhost, unless you mute this one too. And then I'm going to import all my JavaScript just like we had before. So that's the HTML. So that's the HTML, and the rest is in the JavaScript, which will take a lot longer to go through. Can Josh be my teammate? I mean, no. WebSockets can send any of USV string, array buffer blob, array buffer view. Mixing types probably. The problem is I don't know if you can read the file. That's the one I keep getting hung up on. You can't write any JavaScript that reads files off the file system. I think that's something that the form is specifically allowed to do through a file picker. So somehow you have to read that and then get that into your JSON or otherwise. Because you can always base64 encode the image, but you got to get the bytes of the image. So you can make an Ajax call with a multi-part form request. You can do that with JavaScript. So you have some form of access to the file, but I don't know if JavaScript would let you access the raw bytes, rip it out of the multi-part form format, and then put it into like a JSON string or otherwise base64 encoded. I think it will. Actually, you know what? I do know the answer to this. It will. You can do that, right? Or did they do that with... So you can send images over WebSockets, and that's been done. But was it with... I don't know why I don't know this off the top of my head. But was it with... was it in the multi-part form data format? I'm going to say there's a way to do it. I think there's a way to get the raw bytes, but you do have to go through a form still. Because the user, you can't open files in JavaScript. The user has to explicitly have that file picker open and then click on a file to submit. Like when you submit to upload, when you submit to Autolab, like we have to have that file picker. That file picker looks the same on just about any site you visit, probably actually on every site you visit. What am I saying? That file picker is going to look the same on every single site. You've never seen a custom file picker. You've never gone to a site where it says, click here to upload a file, and some really weird interface pops up. It's not going to happen. It's going to be the same on every single thing, and that's for security reasons. We can't, as developers, as web developers, can't control the file picking process. We have to put an input of type file, and then the browser will explicitly ask the user, and the user has to choose a file. We can't do that with code. Not allowed. And it's good that it's not allowed because that's a huge security risk if we can write code that opens their files without them knowing. Huge security risk. All right, so let's go through this JavaScript. So the first thing we do is open a WebSocket connection. And always do this, please. For this homework, obviously, you're just going to cut and paste my JavaScript code or download the file. But when you're out there outside of this homework, please read the host dynamically. There's a temptation. So the alternative would be localhost 8080. This would be the alternative. You're going to put this in your code, and it might even appear multiple places whenever you need to access the server. And then when you either change the port number, this breaks. Or more importantly, when you go to deploy, this breaks. So you go to deploy, you buy a domain name, you host it at that domain name, and now the host is no longer localhost port 8080, it's yourdomainname.com. And everything breaks, and what are you telling your supervisor or your project manager or yourself? Well, it worked on my laptop. It's because you hard-coded to your laptop. That's one of the biggest causes that I see, at least in web development. That's going to be it worked on my laptop, but when I went to deploy, everything broke. If you do window.location.host, that's just going to take whatever the current host is, whether it be localhost 8080, yourdomain.com, CSE 312.com, whatever that host is just going to grab that host. Easy, doesn't break. Like it's always going to get the right host if you read that dynamically. Create a variable for my WebRTC connection. A little usability, so you can hit enter instead of clicking send to submit messages. Just a little bit of UX. I don't do much UX, but sometimes I add a little bit in there. And then the send message method, I'll take a little bit of time to talk about this. Control-C, Control-V. To send a message, we're going to read that input. And we've done this before. This is more review. We're going to read that input. That's your comment. Another little bit of UX, always blank out the comment. I learned this one the hard way. Refocus the chat box. So I want the feature where you can just keep typing, type a message, hit enter, type a message, hit enter, type a message, hit enter. I want you to be able to have that usability on there. So a little bit of UX. If you don't blank out the comment box, there's, I guess there is, if everything's working right, there's some feedback that the message went through, but it's still annoying to have to delete your old message. But what I set up a chat app, had a lecturer use the chat app, and it was using polling. So you would hit a message, hit enter to send your message, and then it'd be up to 1 second to be able to see your message. Well, I wasn't clearing the chat box, and they were waiting up to a second to see their message, so there's no feedback that the message worked, and they would just keep clicking the button over and over, like, come on, work, work, work. And then they'd end up spamming the message like 10 times. I'm like, why is everybody spamming this thing? And it was because my UX sucked. So usability is helpful at times. And then the big one, we're going to use this socket, the WebSocket connection, and send data over that connection. On the front end, it's really simple. Whatever you give this JavaScript, the libraries are going to convert that into bytes for you. So I'm just going to give it a string. I believe you can even get away without stringifying this. I think you can just send the object itself, if I'm not mistaken. But I'm going to give it a string. I'm not worried about encoding it into bytes or anything. I'm just going to give it that string, and then it's going to send that to the server. So over this WebSocket connection, your server is going to get this data as the payload of a WebSocket frame. So now to get your first frames, you fire up the front end, or rather you host these files from your server and then run your server, go to the front end, and then send a chat message. That's going to give you a WebSocket frame, and then grab that frame. As soon as you call receive, grab that frame, and the simplest thing, just print it to the screen immediately as a byte string, and then use that for your test case. So get a chat message on there, a nice short message so it's not overwhelming, and then, or I shouldn't say so it's not overwhelming. So it's less than 126 bytes, so you don't have to handle the longer payload links immediately. Make sure you're just starting with a 7-bit payload link. Keep it simple to start with, and then you can add the other payload links when you get to Objective 3. And that's your first test case. Adding messages, I don't think I have to talk about this much, but I do want to talk about it in the context of chat history. So in Objective 4, you're going to add the chat history feature, which is going to be a regular HTTP path, which this is where we are using Ajax. This is what I was thinking of talking about earlier. So for this, we're going to create an Ajax request and then make a Ajax request for chat history. And then when I get the response, for each message, this is going to return a JSON string representing an array of objects. And for each object, I'm going to call add message, which is going to read the username and comment from that message and add it to the HTML of the chat div. So I'm going to add all of those messages to the page so everybody can see that, see the chat history. And this is going to be called onload. So this welcome, I'm using that same structure as the JavaScript that you're already using that's adding JavaScript to the page. Just this silly little line that does almost nothing, but proves that you did call the JavaScript and run it. That's also going to call get chat history now. And if you want to comment out this, I was commenting this out for testing. For testing, if you want to use that as well. The start video method, so you don't have to click the start video button every single time. Just saves a button click, well, 2 button clicks when you're testing Objective 5. But it can break things or just make things annoying when you're testing Objectives 1 through 4. So I left it commented out. So this is called onload, just like before. When the body loads, we're going to call welcome. Welcome is going to call get chat history. Get chat history sends an Ajax request for the chat history, and then renders it all to the screen. So the first thing, somebody goes to your page, the page loads right away, then an Ajax request is fired off for all of the chat history. You get the chat history, renders it to the screen, and you should be able to see it'll be very brief, but there'll be a very brief delay from getting that chat history. Extremely brief because your server and client are both on localhost. There's like almost zero network delay, and you're just sending a few pieces of text back. So there'll be almost no delay, but there should be some slightly perceivable delay. Actually, maybe not even perceivable in this case. But when you're over a network and your chat history is 1 million messages long, first, don't render all 1 million every single time somebody goes to the page. But if you are, you will see that delay. And you want the page to load. It's going to take a second or so for a human to just parse your interface and see all the features that you have, all the buttons that are there. And then as they're doing that, then the chat history pops up. And you keep the user engaged instead of having them wait like a full second for the page to load, which you would do with HTML templating on the server side. So kind of a flashback to that topic. And then let's get to the fun stuff. Any questions, by the way? Where is the chat message? An actual question. For sending WebRTC to the other users, do we have to add the fin, reserve, etc. in a new frame? Or do we simply just send the payload back? You have to have the fin, reserve, etc. in your new frame that you write. You have to have all that. But your fin, reserve, and opcode are all going to be the same for every single frame that you send. So you can just straight up hard code that byte. It's going to be 100000001. So you just make your first byte that. Then the next byte, your mask bit is 0. And then your payload length, you have to do all the payload length stuff. So payload length takes a while, but your mask bit is 0 and your mask doesn't exist. Your first byte is fixed. So the only work you really have to focus on when you're sending frames, when you're creating frames to send, is getting the right payload length. That's the bulk of the difficulty with that one, which does get a little tricky, if I'm being honest. You got to really think about your bit level manipulation, which, if you haven't ever done before, it's going to be a few Google searches, like how the hell do I do this in Python? How the hell do I do this in JavaScript? How do I do this in Go? But those have to be there. The structure of a WebSocket frame, you have to follow that structure for any information that's sent over a WebSocket connection. Where's the chat message dictionary passed into add message setup? What does that mean? So your server is going to send back an HTTP response. The body of that response is going to be in this .response. So your server is going to send back a JSON string, which represents an array of objects, as the body of an HTTP response. The browser is going to do all the parsing, read the headers, content length buffering. All that stuff's going to be done by the browser, and it's just going to give you this .response that is the extracted body of that HTTP response. So I'm grabbing that in the message, parsing it as JSON, and then iterating over the array after I parse the JSON string into a JavaScript array. Now I'm just iterating over each message. Each message here is going to be an object with username and message if the server sent back everything in the right format. And then I'm calling add message with that. And that's how we're getting the dictionary. So the hidden part is what you're coding in Objective-4. All right, on message, let's make some sense out of all this. We still got to talk about all the WebRTC stuff. It's not overly complex, but there is a decent amount going on here. So let's talk about this and kind of refresh everything we talked about last lecture. And I'll jump around a bit here because it doesn't make too much sense to go in absolute order. But I will start on this one. The socket.onMessage says call this function whenever we get a WebSocket frame. So again, the browser is going to do all of the frame parsing itself. On the front end, you don't have to care about fin bit, reserve bits, payload length, none of that. None of it at all. The browser is going to do all of that, and then once it extracts the payload from a WebSocket frame, it's going to call this function with that payload all extracted and everything. You don't have to worry about the details of the protocol on the front end. The browser just does it all. So whenever we have a WebSocket frame, the payload is going to be right here. Sorry, the whole message. And then we're going to extract the payload as .data. These are always going to be JSON strings for this homework. So I'm going to parse that, get the message, and then each message has a message type. These message types are completely made up, just so you know. The message types are just my way of having 4 different types of messages being sent over our WebSockets, so we can distinguish between those messages. So each message, like it'll be in this kind of format. Everything we send over this WebSocket connection is going to be an object that will contain a message type, specifying the type of the message. And then for each type, we're going to have additional key value pairs based on what type of message that is. So I'm going to read the message type, and depending on that type, I'm going to do 4 different things. We have our 4 different message types. Either this is for chat, for objectives 1 through 4. It's an offer, it's an answer, or a candidate, are 3 WebRTC methods. All right, so now I'm jumping around a bit here. I want to go through this in chronological order. The code has to be organized, like all of the receiving WebSocket messages are in one spot and stuff. Let's go through this in chronological order. So somebody fires up this site, either you uncommented that line in the welcome method, or you clicked the start video button. Either way, start video is going to be called. So start video is going to set up our WebRTC stuff. And again, this is going to be a theme when we're going through the front end code. The browser is going to do a lot of the actual stuff for us. So most of what we're doing is calling methods of the WebRTC API and then taking whatever response we get, not caring what's actually in that response, what it actually represents, and then just sending it where it needs to be sent. So the very first thing, if we're going to start a stream, we need an object saying whether we want video and or audio. So if you want just the chat app, you want to use all of this code, but you don't want to have video, you just want chat, just set this to false. Problem solved. We want both audio and video. We're going to do full voice chat, video chat. Then we're going to get user media. Oops, with the constraints. I got to highlight all this. We're going to get user media. This magical little function right here is what's going to access your webcam and your microphone. And this API is extremely simple. To get that video working, very simple. You call get user media. This is I shouldn't say super simple because you might not have seen this yet. This is using promises in JavaScript. So JavaScript is naturally asynchronous. And if you haven't coded much JavaScript, when you do start coding in JavaScript, that will catch up to you if you don't know what that means right now. But JavaScript is completely asynchronous. By default, it is built to be an event-based architecture from the ground up. So in 1.16, when we did event-based architectures and concurrent code, and we had to import the akka library to be able to get things working concurrently and have all this extra overhead to have an event-based architecture, JavaScript is just out of the box asynchronous. Whether it's in the browser or Node on the server side, it is asynchronous, which means whenever you have any input or output, whenever you have any operation that's expected to take any amount of time, that's going to be called asynchronously. So when we call this method, this is going to get your webcam, a notification is going to pop up. Do you want to allow this site to use your webcam, etc.? As soon as this method is called and before it finishes, the next line of code executes immediately. That method call happens concurrently. So if you just call this method and then start processing other things, things are going to break. Because you're starting to add the video and do things with the video element before the user allowed you to accept that, before the user said, yeah, you can use my webcam, you're trying to process that. So what we use are either callbacks or promises. I'm using promises right now. The return value of this method is going to be a promise. That promise, I'm going to call the then method, which means don't do this, or how do I want to word it? Do this only after you've done your thing. So we're taking asynchronous code and saying, no, I want this to behave synchronously. I want to wait for this thing to be done, and then I want something else to happen. And then once it's done, it's going to call this function. I'm going to define an anonymous function here that takes in a media stream, which is what this is going to do when it handles when its promise is fulfilled. It's going to call this function with the stream that was opened through the user's media. So you click, yeah, you can use my webcam. We're going to get access to that stream in this function call, and then the rest of this is the function itself. So this code is going to be called only after we have access to the webcam and microphone. First thing I'm going to do is get my video element and set the source of that element, the source object. So just like if I did src equals some MP4 file, same thing here. I'm going to set the source to the stream, the media stream that we opened. This code right here, if I just cut this off right here, that's all I need to actually access a webcam. That's what I mean by when I said super simple earlier. Aside from the promises syntax, if you're not used to that, this is all we need to be able to read the webcam and display it in your browser. So to do everything locally without the WebRTC stuff, everything else is the WebRTC stuff. This is all you need to read somebody's webcam and then display it to them. So if you just want to build an app that accesses your webcam and shows it to yourself, for whatever reason, I don't know, it's not super useful, but this is all that it takes. That's it right there. Browser does the rest. That's what I meant by super simple. So don't be like, oh, he said super simple, but there's all this other crap. Just getting the element and setting the source in the promise, in the call, in the function for the promise of this call. So just 4 lines of code. You can read your webcam. You can get your webcam data. Okay, then the rest is the WebRTC stuff. We have to set our ICE configurations. The only thing we're doing here is setting the stun server so we can get our public IP and port like we talked about last time. We are going to use Google's public one. If you want to use a different stun server, go ahead. This one works, so and it's free and everything. If you're worried about Google accessing your data, I am a little concerned about that, but not overly so. Like I said, next semester, I think that might be part of the homework is to write your own stun server. But for now, we're going to use Google's free one. I'm going to create my peer connection with that configuration. This gives me that connection object in that variable that I declared way up here. So I need to access this variable across many different methods. So I'm going to put it at the package level. I'm going to put it up here so all of these methods can access that connection. But here's where I'm first creating that connection, is creating a new connection with that configuration. I'm adding my stream to that connection. So now when I do finally negotiate some peer-to-peer stuff, I have my stream set to it, so I can start sending that stream and streaming my stream over to it. And then I'm going to set another, what are these even called? A function, a listener, I guess would be the right term. Add a listener that's going to listen to the add stream event, which is going to be a function which is going to get the element for the other video and do the same thing that we did for our video. Whenever a new stream is added to this after ours is added, once another stream is added, I want to add that to the other video element so I can see the other person's stream. So when another stream is added, I'm presuming that that's going to be the one from the remote peer of the WebRTC connection. I'm going to set it to that other video so I can see that. And then this on ICE candidate, this event, the ICE candidate event that I'm listening to here is going to occur whenever I have a new ICE candidate available. So when the connection is being negotiated, the browser is going to send a message to the stun server, get the IP, public IP and port, generate an ICE candidate, and then call this function and say, yo, I got a new ICE candidate for you. And what we're going to do is just ship that over to the signaling server with the right message type, and then the candidate that the browser gave me, I'm going to set that as the candidate. So this format, all of this part of the format, that's just stuff that I made up for the homework. We can choose whatever format we want. If you want to change that for whatever reason, I don't know why you'd want to, but if you want to change this format, go ahead. But this is the key piece of information. We need to get this information, which contains our username fragment, our public IP address, our public port number, everything that gets around the NAT. All of that information is in this data.candidate, and we need to get that information to the other peer. That's our goal. That's our only goal. This information needs to get to the other peer. We're doing that through a JSON string being sent over a WebSocket to a signaling server, which is going to send that to the other peer. That's our solution to that problem. But there is no standard solution. There's no RFC that says you should have a signaling server and use WebSockets and JSON strings in this format. All that stuff's just made up. Anybody establishing a WebRTC connection just has to make that stuff up, one way or another. It should make sense. It should generally make sense. And I think most of the time it's going to be something that looks like this, with a signaling server and WebSockets and a message type attached to it. But it doesn't have to be. And if we had more than just two peers, we would also have, actually, never mind. We would have the username that you want to connect to as well. We could add more information to it. But the crux of this, the most important part, is this data.candidate, which came from the browser, which came from the stun server in this instance, which could also include a turn server. Other things could be involved here. That information needs to get to the peer so that peer knows how to connect to us. That's what's important here. So when you receive this message, again, your server is just forwarding that to the other peer. So each peer is going to send its ICE candidates when they are ready using this code, and then each one is just going to, the signaling server is just going to forward those to the other one. When we want to connect, when you click that start video chat or whatever I put on the button, what did I put on the button? Start video chat. I was testing, it used to be called Start Video Roulette, but I changed that before release. I should have left it. I like that better. You don't know what you're going to get. So I'm going to go to that connection, create an offer. This is also going to use promises. So I'm going to create an offer, which is going to give me an offer object in all the format that I want it to be in. That's going to take a while. It's going to be called asynchronously. Actually, it might not take a while, but it will be called asynchronously. Once the promise resolves, it's going to call this function, which I'm going to take the offer and just mostly just ship it. I'm going to ship it over to the server. This WebRTC offer is the most important piece of information. Our only goal, well, or one of two goals here, is to get this offer to the other peer. And we also need to set the local description of our connection to get our information set into that WebRTC connection, which drives me a little, I don't like this a little bit, because why doesn't create offer also set the local description? I'm sure there's a good reason for why it doesn't, but I feel like it could do that for us. But anyway, send it. And then that brings us back up to these messages. So the offer is sent to our signaling server. Signaling server sends that offer to the other peer. The other peer is going to get the offer and set the remote description. This one absolutely makes sense why we have to set the remote description. Set the remote description to the offer of that message. So we sent the offer in here. So we got to get this piece of information, which is at the offer key. So I'm going to read that offer and set it in as our remote description. So I know when I get messages over this WebRTC connection, I'm going to read that remote description to figure out how to process it, or rather the browser is going to. And I want to create an answer, again, uses promises, and then sends the answer over the WebSocket connection and sets that as the local description. The answer and the offer have mostly the same information. So the local description from the peer that's being asked to, being offered to establish the connection is going to set their answer to their local description. The one offering the connection is going to set their offer to the local description. Answer and offer both contain the same information. So they can both be the local description, whether it's answer or offer. It doesn't matter as long as you get the information. And here the offer is being set as the remote description. On the other side, when you get an answer, the remote description is going to be that answer. It's the same information, offer and answer. It's very much same information, mostly the same information, I should say. So when we get that answer back, all we need to do is set that remote description. We don't need to send anything else to the signaling server. We already sent an offer, got our answer. We're kind of done with the signaling server for that. And whenever we get an ICE candidate, we're going to set that ICE candidate that we were sent to the connection to be able to get the details of that ICE candidate. And if you send the front end a broken message, you're going to see this in your console, which is actually everything. Right at 10:50, we got through every part of that. Any questions? It is actually a track. Any questions about all that? So quick reminder, I won't have any lecture questions next week. It'll be review, tips, tricks, extra stuff, demos and stuff. So do with that what you will.